So just a few highlights in the code for Project 1. This was brought up today, and I think it may be not very clear, but when you're inputting the values that you're testing for in the scanner, you're testing for a total of 8 semesters, right? 2 semesters per year. So you need to somehow capture the year that the student is at. You need to capture the name. And for each year, then you're going to average that year of those 2 semesters, and of course give the calculation for what the credit would be. Now this is your final display, so this means that you have to accept input for a name. You have to have the freshman year and the 2 semesters, a fall and a spring, and you're calculating it. And then the final calculation is adding up the total credits. All right, so that's notionally the requirements. Now, some of you said you're having difficulty. Would anyone like to share real quick what is a question you're having difficulty with? Or one area that's causing concern? Anyone? I'm not trying to put people on the spot. We just want to help. Is everyone comfortable accepting the inputs? So you got scanner next int will give you the year. Scanner next double will give you the GPA. Scanner next line will give you the string, right, that you would use for the name. And then the rest of it is just simple calculations using what you've learned so far on how to format an algorithm. Did I answer all the questions just like that? Is that? Yes.
To achieve the whole look like that, do we system outprint? Do we do so in terms of spacing, or is there a way to do like columns per columns?
I believe you all looked at the system output print line or print format. Did y'all remember using that in your Xi books?
Only for doing decimals. So like
Okay.
you system out print F if you're doing the thing where you stop the decimal places where it's at.
Okay.
Other than that, it doesn't really go into like how you actually use it.
Okay. So let's look at so you have different flags you can pass. You have the width, precision, and the conversion. So for example, here the format is giving you, let's see, so the N gives you the new line, right? The D gives you decimal integer. Let's go back real quick here. There's a lot of resources on how to do this. So the arguments for this will give you various ways you can do it. Now the print format may seem complex to you, and if it does, you can do system out print line and count out the spaces and do it that way. But the system print format will actually give you a clearer representation how to do it. This guy, Beldung, he does a number of different tutorials on everything in Java, so you can go through and read the different formatting guidelines. So you have the locale, which would be English, French, Spanish, Chinese, right? Whatever the locale is, whatever the language would be. The format, and then the arguments. So if you look at this format, you have the percent %s exclamation % new line. So this produces this text. Okay. Let's see. S formats strings, D is for decimal, F formats floating point, and T formats date time values.
What do you mean by format? Like,
You can add spacing, you can add any number of things to it.
oh, so it's just like the thing that lets you start formatting it?
Yep. So the width specifies the field output for the argument. It represents the number of characters written to the output. So you can specify a number of different things here. My recommendation to you, if you're not comfortable using the printf, go ahead and do print line, but you're just going to have to count out the spaces and input it the correct way. Otherwise, you can use printf with the width flags and these modifiers, and it will present the output in a very exact outputted format. So for example, if your calculated money that you would be receiving happens to be in the hundreds versus the tens, it would format correctly all the spacing for you. Okay? Now, we're going to talk about some of this today, incremental development. What I mean by incremental is you learn how to do it, do the format, and then you go, okay, I'm going to test it with adding it one more time, compile it and test it, add a little bit more to it, compile it and test it. It's incremental. And it's very basic. It's very easy for us then to pick up things because we develop trust in what we're seeing, understanding the syntax, and so forth. Yeah.
So if we use printf, does like putting in a bunch of spaces still work? Like you can still do like everything you can with like normal print line. It's just you have like more tools, I guess.
Yes. Yes.
So it doesn't behave the same way as print line though, because it doesn't automatically end with the new line, unless you specify.
Unless you specify with the new line character at the end. Yeah. Print format allows you to take tabular data and organize it in a tabular fashion. That's the intent of it. It allows you to format things in ways to add spacing in certain spots to make it all uniform. Okay. All right. There's no extra credit for using print format. So if you don't want to do it, you don't have to. But if you want to learn more, that's the best way to go. Okay?
So we would
Yep.
still have to have that final output, or
Yes.
like exactly the way you formatted?
Yes. Yes. So you'll have to figure out how to put a $ on it.
No, I meant to say like the way you, exactly the way you printed it that way.
That's the intent.
The spacing and everything, or like as
No,
close
I'm
to
saying
that as
like
possible?
You're wanting to make it tabular, right? So this is kind of a tabular format. This is technically a column, right? Then you have the next column, the next column. All you're going to do though is you're going to do that with spaces. So you have system out print line for the first one, very easy. There's nothing too difficult there. The next system out print line is going to be calculating so many spaces, and then this value, which is going to be different based on what year you input. So if the starting year is 2000, then this will be 2000, right? And then you have a spacing, and then you're going to do it again. So this is the second system out print line. Third one will have GPA, system out print line, right? You're spacing it again, putting the variables. Now you guys know how to do that, right?
Yeah.
You know how to put in quotes and tab space, all the way out, right? Okay. Make sure you put the $ on your values. Okay. Any other questions? As far as your first project, this is a very basic one, very easy. It doesn't matter how you get to this point, right? There's many different ways to get to this point, to input the data and get it to this part. But you have the basic tools so far. You have the basic tools of using the scanner, You have the basic tools of understanding how to create a mathematical algorithm for calculating. You have the basic tools for doing print line statements. Okay. All right. When you turn in your assignment, this is what I want you, the format I want you to have your code in. When you turn it in, at the top of the page, use your comment blocks, name, whatever your name is. Okay. How do you spell your name? Kailani? Kalina? I'm sorry, I'm getting confused here. Kalia. Where's Kalia at? There you are. Okay, spell your name for me. Okay, and then your last name. Okay, make sure you put in the last name. You're going to put in the date, right? So it'd be what, tomorrow's the 9th. And you're going to put in the class, CS227. Okay, make sure that's at the top. When you turn in your code, all you're going to do is submit just the Java file. Don't zip it up, just the Java file for this.
So how do you do that?
So when you come in here, I have no submissions right now. I don't have the ability to look at this, but what you're going to do is just upload the file. Okay?
Where do you find the file at? Is it just...
It's in the directory of your IntelliJ. So if you know the branch, there's your project name, there's your source, right? So you're just going to take the Java file, not the class file, the Java file. Because I have to see your code. I have to be able to read it and see those elements. Okay? All right, any other questions? So if you're in the code, you could see it right there, right? You know that's the full path. For your Mac users, if you're in the terminal, you can type PWD, and that'll tell you the path. If you're a Windows user, I think it's DIR. It'll tell you the path. Okay? All right. We're going to move on from this and look at today's lecture. We're talking about loops. So loops, they just repeat themselves. These are code structures that repeat so you don't have to keep repeating the same action over and over and over and over again. A great place to use a loop would have been in your current project, wouldn't it? Because you're inputting the same pieces of information kind of over and over and over again. And you can control that with a loop. Common terms for a loop, you have the loop body and you have an iteration. So an iteration is the amount of times that you're going through the cycle of the code. The loop body is what's inside the loop. So a loop is kind of like a branch. It's like a if statement. If the Boolean expression is met, it executes the code inside the loop. Very basic. The difference, though, with a loop is in a branch, if you have an if statement, once you're done with the if, you're done with it. With a loop, it keeps executing it ad nauseum until it meets the condition that allows you to exit the loop. The loop expression always has to evaluate to false to exit out. So let's look at some examples here. So here we have a flow diagram for a loop. You initialize some variables up here. This would be where you type, int number equals 0, and then you check the condition. Is I equal to 10? Greater than or equal to 10. If it if it is not, then it's going to, if it doesn't perform that condition, if it evaluates to false, it exits, right? If it does meet that condition, if I is less than 10, it's going to perform the action in the loop, and hopefully you have some type of logic that will increment or decrement the value till it reaches the condition that you're looking for, and it'll keep performing that loop. So whatever code that you put inside the loop, that's the part that you want to be repeated a certain number of times. So if you're, for example, if you're taking tomorrow's project, you technically, for each year, you're going to perform the loop 2 times, right? And really, you could say for the loop will perform a total amount of 8 times, right? Because you're checking semester 1, semester 2. It all depends on the logic, how you construct your loop. You could have a loop within a loop, which is another way that you could tackle tomorrow's project that's due. You could have a loop that says, do this piece of logic, and then once it evaluates to true, it goes to the inside. You could have another loop that says, okay, we're going to do this piece of logic twice. And so the outer one could be a total of 4 years. The inner one could be the total of the 2 semesters, right? And that's how you would operate your loop. Let's take a look at some common looping expressions. Now, with loops, you can do 3 different types. One of them is considered a subtype of the while loop. So you have a while loop, and you also have a do while loop. Now, the while loop, again, you have the expression, while, Boolean expression, and then some code statement. Can we get someone to turn the lights off just in the front of the room? Do those?
Is that like?
I don't know which one does it. That probably works. That works better. Okay. So we have a while, Boolean expression, and then the code statement that's executed. Every time it goes through this, that's an iteration until the Boolean expression is executed. Let's do an example. We'll create a new project. Again, I encourage you to follow along with me. The way you build confidence and fluency in your coding abilities is to write code. So go ahead and follow along with me. Open up IntelliJ, and we're going to create a new project here. Once you create the new project, we'll just call this loop examples. We'll click on the folder, go down to the source, say new Java class, give it the same name, loop examples. Okay. Let's go ahead and create a public static void main method. By the way, in IntelliJ, you could type PSVM and tab, and it does it for you. Okay, PSVM, public static void main method. And I'll kind of put this in comments for those who want to do that again. Okay. PSVM plus tab, and that will create that public static void main method. Inside of here, let's go ahead and create a Boolean, let's create a couple of variables. We'll have int num equals 0. We'll use the scanner class. Remember, it takes system.in. We'll create a while loop. And now we're going to create the expression. We're going to say num is less than or equal to 10. Okay? Num equals scanner next int. And let's just take our num value and we'll say plus, and then SOUT, system out print line, num variable is num. And then down here outside of the loop, we'll type done. And up here, right before the next int, we'll type another system out print line. Please enter a number less than 10. All right, let's look at the logic of what's happening here. We have a scanner class that we're instantiating, and we're instantiating it with this variable name. We have a num variable that we've declared of type int, and we've assigned it the value 0. Then we have a system out print line method that says please enter a number less than 10. And for my sake, I'm going to make this a print, not a print line. And I'm going to do that so that my input is going to be on the same line as my text. Okay? So now we're going to read the scanner, get the int, assign it to num, and we're going to say while num is less than or equal to 10, num plus plus, which does what?
Just adds 1 to it.
It increments it by 1. And it's going to do that until num is either 11 or, yeah, unless you input some negative number, some insane negative number. Okay? And I'm going to output what the variable num is so we can see it loop through that code. And then when it's done, it'll say done. All right? So I'm going to go down to my terminal. Actually, let's not do that. Let's go down to our terminal. We'll cd to source, to the location of our code. Let me clear this out. I'll do an ls so I can see my loop examples. javac, loop examples. I'm going to compile it. Okay, so it's compiled. Java, loop examples, and I hit run. Please enter a number less than 10. All right, so let's make it fun. Let's say negative 10. Now, let's look and see what happened. We can see that the code executed and started at -9. And we know at -9, is it less than or equal to 10? Yeah, so it still meets the condition. So it increments, it prints it out. And then it goes back up and does it again. And it keeps doing this until the variable equals 10. So in our code example, we're testing for this logic, right? Okay, let's go back to any questions so far?
Mine printed up to 11.
Huh?
Mine printed up to number 11.
Yes, the num is 11. So is it less than or equal to 10? Yeah. So think about why that happened.
It's because 11, 10 is still less than or equal to 10 because 10 is equal to 10. So it ran one more time.
Yeah, so num is going to be equal to 10, right? And so it's going to enter again. It's going to add the number, and then it's going to output it. Now we could solve that problem one of two ways. We can move this to here, or we could just say like that,
Oh.
right? Both of those scenarios satisfy the calculation. If you do both of them together, well, watch what happens when you do both. It's just going to make it exit a lot quicker. So I'll do -10. It's going to exit at 9. It'll never go to 10. Even though right here, if we were to do another system out print line,
It would print 10.
save it, come down and compile it again. -10. What you could see is that it still increments, but as it comes up to the next cycle, we find that, okay, so it's completed its clause. Now num is not less than 10, so the Boolean expression says you can't do this anymore, right? All right, let's go back to our slides here. So this is the basic while loop, right? There's also a do while loop, and do says do this, and then the while expression is at the bottom. So if we were to do a do while loop, it would look something like, well, let's take, we're gonna cut this, I'm gonna say do while.
So it does the same thing.
It does the expression first, and then it does the loop first, and then checks the expression.
Okay.
It's just the exit point has now shifted. Okay. All right. So that's the while loop. Clear examples to this, you could use it. For example, we have a current power and a user character. We could say that the current power is equal to 2 and the user character is y. So we're going to do this while the user character is y. So we'll outprint the current power. Current power equals current power times 2 and user character. And we're going to ask for the next, which is a string, get the character at the 0 index, which would be the first character. And if that character is not y, then it won't continue. So we're asking the question, do you want to continue? No, then it won't continue. Do you want to continue? Yes, then it'll continue. This is another way of using a way to satisfy the calculation. So in this example, the calculation doesn't necessarily have to meet a criteria for the expression. You're kind of separating the two. Does that make sense? Okay, let's go on here. Other loop expressions. Username is greater than 0. User number is greater than 0. So here we're using inside the print line, we're doing a modulus, and we're saying, okay, whatever that modulus is, print it out. And then we're saying user num divided by 10 back to user num. At some point, if that value is greater than, if it meets the criteria, then it's going to exit out. Okay. Again, these are all examples where we're using the calculation. We're making the Boolean expression that's evaluated to depend upon the calculation. There's many different ways you can do the Boolean expression. It can be based on your user input. It can be based on a calculation. It can be based on the clock time, system clock time. There's a lot of different ways. All right, so some common errors. Let's have fun here and show what happens when we don't do this right. Let's say yeah, it is unreachable. Okay, there we go. So let's talk about what's going to happen here. Look at the code. Somebody who has not answered yet. What do you think's going to happen? All right, let's run it. Zach, give me a number.
6.
Okay. What's happening? Yeah, it's an infinite loop. This program would run on forever
Jeez.
until I run out of memory in my computer. I've got a very robust computer, so it'll be a long time. All right, if you ever run into this situation, remember Control C. Okay, that'll kill the program.
Did it still take a pull from that memory, or?
It would keep going until I ran out of memory eventually.
Jeez.
Okay. Now there are situations where we want the program not to stop. There are situations where we set true and it's supposed to run until it reaches a certain criteria. And we're going to get into that criteria later, but sometimes if we want the criteria to keep going, we could have a scanner input. Let's see, next. Let's see, where is it at? Character at 0. System out print line. Do you want to continue? Y or N? Let's see, we're going to do character condition. Well, let's do it like this. YN. Okay. If Y equals Y, whoops, and this is the power of the break. You can use a break in your code to short circuit your code if certain conditions are met. So in this scenario, when we run the code, we could take this out now, compile it, run it, enter number, I'm going to say -10. Do you want to continue? Oops, my code is wrong.
I was going to say, yeah, isn't it like, yeah, you give it opposite?
Yeah. Well, let's do Y, right? Because my code is wrong. So if my code does not equal Y, there we go.
Yeah, okay.
Compile it again. -10. Do you want to continue? Y. Yes. 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 But if I enter it no, it'll break. It'll exit, right? All right, so that's the break command. You can use the break to exit, short circuit from your code. All right, let's go back and pay attention to those things, though, because you can run into infinite loops. And if you do, don't freak out and call me on the phone and say, Mr. Rogers, I can't get my program to stop. Because you can, just use Control-C, or you can power off your computer, one of the two. All right, well, let's go on to the next one. All right, here's some more while examples. This is what we call a sentinel value, though, right? We're checking a sentinel value to see if it meets a current condition. And we've shown you a lot of sentinel values. Sentinel values are the value that you're checking to make sure whether or not you want to continue with the current scenario, okay? All right. Any questions so far? Something else I want to show you, you can declare your variables like this. Keep them all in one line if they're all of the same type and you're not going to assign a value. Okay, so you can declare them all up front and then come down below and assign them the different values. All right, for loops. We're only going to be looking at one type of for loop, but there is other types of for loops that you can use. But let's go ahead and kind of talk through this. Your for loop, it's broken into three parts. You have the expression that declares the value or sets the initial state. So a common one is to say int I equals 0. That is the initial expression. Then you have the condition, and it's separated by a semicolon. It's very important you put your semicolon to separate your expressions here. This expression will be the Boolean expression. So you could put true in here if you wanted to, as long as it evaluates to a Boolean expression, right? If you have false, well, it'll never run, okay? But you could put true. The typical expression would be to say I is less than some number. So you want it to run in X amount of times, okay? And then the update expression is the incrementer. Typically we'll say I++. Or if you want to do a decrementer, you can say I minus minus, okay? And then there's the loop body, the statement. Now, if you're thinking about this for your project and you wanted to do this, you could write your code for your project using a for loop, right? You could declare all of the initial expression, the condition expression, and the update expression so that you're not repeating your logic over and over again, okay? All right. Okay, again, here's the typical example for int I equals 0, semicolon I is less than 10. This is the conditional expression. Has to resolve to a Boolean response, true or false. And then the part that increments it. Now, you can have a pre-increment, which means that the value of I is incremented before entering the value. I don't recommend that, but you can do that, and there are logic reasons why you can, but for readability's sake, always do post increments. Post increments are easier to read and it makes more sense. It helps you to stay on top of the logic of what you're doing. Okay, let's run an example here. We'll take our while loop, and please enter a number less than 10. So we're going to say for int I equals 0, semicolon, I is less than some number. We'll use the value that we're inputting in. And then we'll say I++. Okay? So, system out print line. We'll just do I for right now so you can see what happens. All right, so let's compile it. Guys, if I'm going too fast on typing this code, please let me know, because I want you to kind of participate and do this along with me. We'll run the program. I'm going to enter 10. And you can see from the code that it just increments up. It starts at 0, and it goes all the way up to 10, and then it exits. It meets the criteria. The number is the value that I gave it. I put in 10, so I is less than 10, and it continued. As soon as I reaches the same amount, well, it meets this expression, and it exits the code. Okay, any questions so far? There is another type of for loop, but this type of for loop works with arrays and collections. And I believe you're going to get into that in a couple of weeks, that other type of for loop. Okay. So here we have same example. We have this scanner next int. We're assigning the value, and then some value equals, a value sum equals 0. We're getting the value. We're doing value sum plus equals current value, and then we're doing a mathematical operation on it at the end. Okay. So what is current value? Well, current value is going to be whatever this is. And you notice that this is being input every time. So current int could be any number of things, right? Automatically left assigning it to the value of the sum. And then outside of this, once it's complete, once it meets this criteria, it's going to take the value sum and divide it times the num values. So how many times we enter a number? It could be, if I say we're going to do this 5 times, well, it's going to iterate through this, do it 5 times, and then it's going to average that value times over 5. Okay? All right, so conditions, when do we choose a while loop versus a for loop? All right, when we want to specify the number of iterations before the loop, like the number of times, or the number of iterations is not easily computable. Maybe we want it to happen until the user inputs a special letter like Q for quit or something, okay? So let's go ahead and iterate through a string. I'm going to go back to our code sample. Let's see here. We're going to copy this real quick to make it easier. And paste this in. Okay. In IntelliJ, if you want to quickly expand and contract, you just double click on the tab, and that will give you better visibility of what's there. So let's look through the code real quick. We initialize the scanner object. We declare a string for an input word. We have an int for the number of letters, and I, which is probably an index value. We give a system out print, enter a word. We capture that word with the scanner. We have the value, the number of letters is set to 0. We're going to set that in a moment. We have our index value that here we're using, that's already declared up here. We don't have to say int I because it's already created for us. We say I is less than the input word length. So whatever word you type in it's going to take that length, and then we say, okay, do our iteration, plus plus I. All right, so let's go ahead and run this and see what happens. Make sure we save it. Enter a word. You guys have a word for me? It must be a hard word because y'all are having a hard time.
Bananas.
What's that?
Bananas.
Bananas. Did I spell it right? You guys are not grading me on spelling, right?
Yeah, no,
Okay.
no, you're good.
All right. Number of letters is 7. So let's look at what the logic is, what is saying here. We're going to take the character, and we're going to say, is it a letter at that index, right? And we're counting the letters. So let's make it a little bit more difficult. Let's run it again, and we're going to say 600 space bananas. So what happened?
Well, it's all the 6.
Yeah. Let's trade it out and say BA space A. Oh, well, I got to run the program, don't I? All right, BA. Number of letters. So you can see what's happening here is it counts the first letter and then it doesn't match. And so it's looking at this input length and it doesn't know what to do with it. And do y'all know why? I kind of highlighted it, didn't I?
Yeah, that's just the next bit.
Yeah. Let's change this to next line. Oh. There we go. So it counted 7. Are there 7 letters in bananas? So what it's doing here at each line, it's interrogating, and it says if it's a letter, then increment. Let's add to our code and say else not a letter. Well, of course, in quotes. Pilot, run it again. All right. So it's evaluating the caret, the bracket, the letter A, the caret, the bracket, the letter B. Not a letter, not a letter, not a letter, right? Number of letters, 2. And does that match the criteria? Yeah. Now there are instances where this is very valuable. I think you all did a lab last week where you had to evaluate what was at each index, right? For the name lab, you all remember that? This would have been helpful for you all then to kind of put that into practice. All right, let's go back in. Any questions so far? All right, let's go on. All right, nested loops. This is inner loops and outer loops. All right, so we have some common examples here. We have a while loop, and this is a histogram. Okay. It's going to take the next int and say the number of asterisks that are applied. If the number of asterisks is greater than or equal to 0, system out print line depicted graphically. It takes the number of asterisks that you input, and then it, for I equals 1, I less than number of asterisks, the number that you are saying, system print that asterisk. And then at the end, system out print line, a new print line. Okay? All right, let's copy the code here and just take a look and follow this example. Okay. So we'll compile it. Enter an integer, okay? Negative to quit. So let's say 1, okay? It quits. Let's run it again. Let's enter 20. So it has counted out the number of asterisks and it's printed it. Now, there are a number of different ways you can use these double for loops. If we were to take this a step further, and let's say that we have a for loop, int, this is the year equals 0, and actually let's do it like this. Years equals 1. Years, I gotta make the variable sound right. Years entered equals 1. Years entered is less than or equal to 4. Years entered plus plus. Okay. Create my scanner. System out print line. Please enter a school year. Hopefully you kind of caught on to what I'm doing here. Right? So scanner, next, int year, do another for loop, int, this is going to be semester, let's do 1, semester is less than or equal to 2, semester plus plus, please enter GPA for semester sim. Scanner, next, int, let's see, double, right? Double. I'm incrementally programming as I go. As I create as I see the need, I'm creating the variable and going back, right? So GPA, right? Now, based on that logic, I would enter 4 years total, and for each iteration, I'm going to do a semester, 2 semesters. So if you think about how this code would hit, at the first year, I come into my logic, and for that first year, it's automatically going to run the expression twice for this inner for loop. Every iteration will complete the inner iteration, the number specified. So year one, it comes down to the semester for loop, and it's going to do that twice before it exits and comes back out again, right? I see some of you taking pictures. You're like, I'm going to try that. All right. So this is an example of using an inner and an outer for loop. All right. Any questions so far with that example? Okay. All right. Let's go on. So we have the break, and we have the and continue. Now you guys understand the break. If a certain condition is hit and we want to exit the for loop, we want to short circuit, get out of it earlier, then that's where we'd hit the break, right? We also have the continue statement. The continue is a little bit different. In the continue, it tells us when we hit a certain condition, we're going to stop at that condition and go back up and hit the top of the for loop again. So if the continue is on an inner loop, it only goes to the top of the inner loop. If the continue is on the outer loop, it goes all the way back to the top of the outer loop. Okay? In this example, the program code would stop right here and go back up. It wouldn't continue to evaluate the rest of this. And there are reasons that you might want to do that. There are reasons that you may want to exit out and not have the rest of the logic evaluated in a for loop. And that's how you can do that. You can do that with a continue. If I want to completely get out of all of this, then I just put a break. If a condition is hit, break. Get out of that for loop completely. And it'll break all the way out of it. Whereas if you want it to stop at an iteration and go just to the next iteration, that's where you use the continue. Does that make sense? Does everyone understand? Okay. All right, so variable scope and names. Now, there are some times where the value of a variable is declared inside the brackets. If, for example, when you look at this code here, all of my variables are declared outside of the bracket. So the scope of this variable will change over time. However, if I don't want them to change, say I have a value that I want to keep only for that one iteration, I want to declare it inside of the for loop. So the scope of that variable dies inside of the for loop. Let's see. Whoops. At the next iteration, this value would be reset because I'm redeclaring it again. Now, that's also a common error for many people because they think, well, how come my value doesn't increment over the cycle of the iteration? Because you're literally saying, hey, I'm declaring this as new value every time, a new variable every time. So you want to think about the scope. When we think about the scope of these variables, they last for the life of this curly brackets, right? They're not accessible, or the value of them doesn't stay along for the life of the overall object, which is this one, the loop examples. So you want to think about where you declare your variables, because their scope will live as far as where they preside within the curly brackets. Okay? All right. Again, here's the example. This value square, every iteration it comes through, it's redeclared. Which means that if there is a value that was assigned previously, doesn't matter. At the end of this curly bracket, as it hits the end, it goes out of scope. The variable is garbage collection comes in and says, okay, we don't need this anymore, and it reinstantiates it the next time through the loop, which means you'd lose the variable. Now, if you want it to persist, then you need to move it up out of the curly brackets. Okay. Last topic for the day, and this is enumerations. Enumerations are a type of constant. Enumerations are, you use them when there are known types, known values. And so in this example, we have red, green, yellow, and the word done. Red in itself is the value. Okay? And the way we would access them is a little bit different. So let's take.
So red's a string, right?
It does evaluate to a string. All objects evaluate to some form of a toString method. But the way you would access them is a little bit different. You want to declare them outside of the public static void main method. So let's say public enum, the name of the enum. So let's call this light year, and then curly brackets. So we'll have a red, we'll have a green, a yellow, a blue, okay, any number. In itself, an enum is like a type of array, in a sense. Okay, so the way we would access those individual values is a little bit different. We've declared it up there, so now we would say light. Whoops, I can't type. Light year as a variable. My light year equals light year dot the value. These are used for known quantities, and the enums are the expected way for it's the best way for certain types of constants. So if I output this, you can see that it outputs the value that I've assigned it.
So can you assign like a number value to the enum, or is it only strings?
Yeah, it's only, you can't use numbers. You can do, we'll get into it later, you can create a class that will translate to a number, and you can say you can access that value to get a number. But typically, you would, if you wanted to do that, you would do just the string itself. Okay. If you're going to iterate through an array, so you can say for light year, this light year, my light year, and it's probably a bad example to do it that way. Let's do this. Light year values. There you go. Now I've taken the values of these and I've cast them to an array of light years. And then I could do this for light year. This is a different type of for loop. This light year I know I just mind blown some of you. This is using an iterator syntax for going through a collection. This is a different type of looping mechanism, but now if I add the syntax for system out print line and I say this light year, it will print iteratively what I have up here. So if we run it, compile it, and run, you can see it iterates through the values and it prints them out. Similarly, if we wanted to use a different type of we could say int I equals 0, I is less than values dot length. Yeah. I plus plus system out print line values, and we'd specify the index. If we ran that, it will output the same, because we're taking the array and we're using the index for that value. All right?
Why does it go back to like green, red, green, yellow, blue?
Red, green, yellow, blue. So the I is 0, and at index.
No, it's because you have it printed green first, like before the loop.
Oh, yeah, right there. Thank you. Let's go ahead and comment that out just for clarity's sake. Yeah. Okay, so that is the enum. Enums are a great way of storing constants. It could be it could be anything. It could be a list of cities. It could be a list of known values. Whatever it needs to be, constants. Okay. All right. Any questions about enumerations? That's it, and we are done, and we're done on time. That's amazing. All right, guys, if you need to reach me for any reason, I am checking email. Please make sure you're staying up on your PAs and your CAs. If you are behind, please send me an email, and so we can talk and get you caught up. Have a good week. God bless.